slowing down. And again, guys, I write big, so it's going over the thing. Or slowing down. Remember, because it is curved, I know that it is not a constant rate. Alright, so let's continue, and now let's analyze a time and distance graph. So here I have a graph that shows Ashley riding her bike. So apparently she's going to visit her friend Maria. Maria's house is directly east of Ashley's. The graph shows how far Ashley was from her house after each minute of the trip. So let's look at what we notice about Ashley's graph. So if I notice that I can break it down to 3 parts. I can look at this part here as one part of my line, of my graph, I can look at this part here as one part of my graph. And then I can look at this part here as one part of my graph. So let's talk about what we notice. If we look at the pink section, you will notice that my line is increasing. So it is increasing at a constant rate. So I'm going to note that. So this is increasing. Constant rate. If you look at the gray section, you notice that it kind of does what? It's horizontal. So that means that because it's horizontal, it's no slope. I'm not moving. She's not moving. Or she's stable. Or we'll call it stationary. We called it that earlier. She's stationary. Then after being stationary, what happens? She then takes off again. But what do you notice? This line looks a lot steeper than the other. So although I am increasing, it seems like she is increasing at a faster speed as before. So let's look at the questions. So number 1, Ashley rode at a constant speed for the first 4 minutes of her trip. What was her constant speed? Remember, I told you guys to look at the change of y over the change of x. So when I look at this, I can do it 2 ways. I can look at it to see, because I look here, I know it's at a constant rate. I can look to see where she's at 1 minute. So I'm going to circle that. When I look at it at 1 minute, she's at 200. So I know that her constant speed has to be 200. Okay? Meters per second. Per minute, Now, if you didn't recognize that, I could have grabbed 2 points and did the y2 minus y1 over x2 minus x1. That's my second one. Or I could have counted the rise and the run. So if I take 2 points, I'll take this point and I'll go here to 0. So if I go 0, if I go up, I'm at 200. If I go there, I'm over 1. So remember, it's the change of y over your change of x. So that would be 200 over 1, which is again 200. So either way I did it, guys, I got 200 as my constant rate of speed for her first 4 minutes. So what was her average speed for the entire trip? So I'm going to go all the way to the end. If I look here, her total minutes was 10 minutes. She stopped at 1,600 meters. So again, we know that average speed, anything that means 1, I'm talking about my slope. So I'm going back to my formula up here. Change of y over change of x. Since my y is my distance, I'm going to put 1,600 on top. So 1,600 on top. My total distance was 10. So that lets me know that change of y over change of x, divided out, I can simplify my zeros out, and I have 160 over 1, which gives me an average speed of 160 meters per minute. So her entire trip average speed was 160 meters per minute. So number 3, Ashley stopped to talk with friends during her trip. How far was she from home when she stopped? Oh, we already discussed this. Her stopping area is that gray section. So where's the beginning part of the gray section? At 800. So let's know that she is 800 meters away from home. Because I know that she stopped there because that's the beginning point of that horizontal line, which means she's not going anywhere. I got rid of 4, guys. If you want to, you can mark 5 and 6 and make it 4 and 5. I erased question number 4 and forgot to number it. Again, renumber it. So number 4. What is the slope of the line after she stopped to talk to her friends? We discussed this already. If it's a horizontal line, there's no steepness to it. So that means that I'm not going anywhere. So my slope has to be 0. And then, how is the slope of the line related to her speed? We discussed this. The slope of the line is the same as the constant rate. So, just remember, to sum it up again, just remember, decide if it's constant or not constant. If it's constant, it is going to be a straight line. Remember, if it's a positive slope, that means my time and my distance are both increasing. If it's a negative slope, that means my time is increasing, but my distance is decreasing. That lets me know that in my scenario, somebody's turning around because they're going back to the starting point. If it's a horizontal line, that lets me know that I'm not moving. So that means that I have no slope. Now, if my lines are curved in my scenario, in your time and distance graph, that lets me know that if it's curved going up, lets me know that yes, my speed is increasing, but it's not increasing at a constant rate. Same deal, if my thing is going down, that lets me know that my time is decreasing, but my distance is not going very far, so I'm getting ready to slow down, or I'm turning back around to stop at 0, or Alright guys, so real quick, let's go through practice A to make sure you have it. Then practice B is going to be yours to practice on your own. Tomorrow, I'm still not here. So tomorrow, you will do an assignment that will count for a grade. So please make sure that you actually watch this option, you answer the question, and you fill out your organizer, as well as go through all your iBook practice. So let's keep going. Alright, so let's work through practice A together, like I said, and then practice B will be yours to work on by yourself. So let's read each scenarios. We have 3 dogs we're comparing. And there's a table that represents these 3 dogs. There's dog 1, dog 2, dog 3. Let's read each scenario and figure out which dog that it is the table is describing. So, question number 1. Autumn's dog chases after a car passing by their house, then stands and barks. Now, if he's chasing, I know that he is moving quickly. So, just by reading the first sentence, I can automatically get rid of 1 and 2. Because dog 1 is 0, dog 2 is 0, which lets me know that they're not moving. Dog 3 says 24 miles per hour, which could be true, but let's keep going to make sure we're right. Okay, so once he chases the car, he then stands and barks. So if he's standing, I have a horizontal line, which lets me know that he's not going anywhere. So his speed would be 0. Then it says he trots back. Now, if you're trotting back, you're not going at a fast pace. It's kind of like a nice jog to the yard where Autumn puts the dog on the leash. You guys, if you have a dog, you know that if you're putting him or her on the leash, that he's not going to be moving. So again, my line should be horizontal, or I shouldn't have any speed. Then once they're on the leash, then they walk together on the sidewalk. Again, if you're walking, you should not have a fast pace. It's more of a very slight increase to your line. And because they're walking to the sidewalk, you should have a nice increase until you reach that sidewalk, and that's where you should come to a stop. So, looking at it, we were correct. The dog described is dog number 3. And I will tell you why again, looking at the numbers. If he's chasing, 24 is perfect, okay? Because that's more the speed you're going if he's going at a fast rate chasing a car. Then, remember, he stands and barks. Because he's standing and barking, he's not going anywhere. So at 8:01, his speed will be 0. Because he's trotting back, remember I told you guys it's like a nice light walk, jog mixture. Again, he's not going very fast, so 5 makes sense here as his next speed. Because dog 1 is 45, that's quick. You're not going that fast if you're trotting. And then 0, again, means you're not going anywhere. You're stationary or you're standing. The next time, 8:03, dog 3 has 0, which makes sense. Because the next event in my order of events was Autumn putting the leash on him. Remember, I told you guys, if you're putting a leash on a dog, they're not going anywhere. So that would represent the 0 speed mouse, well, where far he's going. And then the last one, 8:04, because they're walking to the sidewalk. Again, you're not going to have a fast speed because you're taking a nice walk. So in this situation, 2 does make sense for being his speed during that time. So that means number 1, dog 3 is Autumn's dog. So now let's look at the second dog, Jordan's dog. So Jordan's dog is sleeping when the family decides to go to the park. The dog awakes and moves about, wagging its tail. The family and the dog gets in the car and drive a short distance to the park. At the park, Jordan runs with the dog. So let's look at it. Jordan's dog is sleeping, so I'm going to go ahead and mark out dog number 3. We've already figured out that dog number 3 was Autumn's dog. So the dog is sleeping. So if he's inside the house, he's sleeping, he's not going anywhere. So I can't narrow anything out yet because dog 1 and dog 2 are both 0. The dog awakes and then move about, wagging its tail. So again, he's wagging his tail. But again, although he's wagging his tail, most dogs like run in place, but they're not really going anywhere at a fast speed. So looking at 8:01, I have 1 and I have 16. For a dog wagging his tail in place, 16 does not make sense. So automatically, I'm going to eliminate dog number 2, which leaves dog number 1. But let's keep checking to make sure we're right, though. The family gets in the car and drive a short distance to the park. Now, the dog would actually have this rate of speed as the car. If a car is driving, it's not going to be 0. Because it's moving somewhere, I know that I'm going to have some type of speed. So I know that at 8:02, the 0 doesn't make any sense there. So it has to be the 45. Once the dog at the park, the dog has to get out, and then it runs then it runs with Jordan. So again, the 8:03, at the 0, that represents the car stopping, them getting out the car, and then the 8:04 represent them actually running. So the answer to Jordan's dog, it is actually dog number 1. So that is how, guys, if you're given a verbal description, you have to go through and actually break it down to make sure that each part makes sense to you and see which part of the story matches the particular graph. So let's now take that and translate it to the graph. So I got to figure out which graph makes sense as for Autumn's dog and then Jordan's dog. Alright, so I went ahead and wrote the dogs under the graph. Let me explain to you why I chose the particular graph for the dogs. If I look, I know that Autumn's dog is not home. So he's not going to be at his 0. He is further away. his speed is going to be faster than dog number 1 because he's doing what? He's chasing the car. If I look at the speed of graph number 4, it is close, is at 0. So I know that automatically that cannot be Autumn's dog, but I'll keep going. He's chasing, and then he stands and barks. This represents this line decreasing real fast to 0. That part represents the dog running, and then stopping suddenly because now he's barking. Then the dog trots back because he's trotting back. Notice that my line is not, he stands and barks. So that horizontal line represents him not moving. So that's the barking part. Then my line increases just a little, okay? Now, because it's not very steep, I know I'm not going very fast, so I can't be running anywhere. So that more represents the trotting back to the yard. Now, remember, once he trots back, she does what? She puts the leashes on him. So he's not moving, he's back at the yard. Then again, it falls back because now he's walking to her, and now she's grabbing him, and now she's putting the leash on him. So again, this horizontal spot on the other line represents where he's getting the leash put on him, and he's not moving. So again, remember, they walk, and then they stop at the sidewalk. So again, notice that the walking part, the last slant, is not as steep as the trotting. Because if you're trotting, I'm going to show you guys like a very light jog. So although you're jogging, you're not running, you're jogging, your pace will still be faster than a walk. That is why that last increasing slope is not as steep, because it was a walk. And then suddenly it stops at the end because they're now where? They're now at the sidewalk and they're not walking anywhere. And that is why it actually levels off again. Again, notice that the speed does what? The distance, yes, speed up, down. So it's a lot of increasing. So it's at a constant rate. But just looking at the speed of us, we know how my line should go. So again, since that's dog number 3, that lets me know that graph number 4 was Jordan's dog. Again, I'm starting here. He's home. He's asleep. So the slight increase is the wagon around in circles. Remember, it get in the car, and then now because he's driving, he's going to have a real sharp increase because now his speed he's going really fast in the car. So my incline is going to be steep from where he started. Then remember, guys, he gets in the car, he rides. So this lets him, he's riding. Now, this is the car when it's decreasing. And it is slowing down. Remember, if it's going down, it's decreasing. So it's probably where you're at the park and you're parking and you're stopping. Okay, then from here, the dog, him and Jordan gets together. That stop, I skipped the spot. That spot here, we get back at 0. That represents what? Them parking the car. Once they get in the park, they run. So that's why, because I'm now running, my line is a little steeper than if you notice in the other line because I'm now running. And then same deal, they ran to the sidewalk. So that levels off to where they are on the sidewalk and they're not moving anymore. Alright, the bottom part, and I'm not able to graph very well because it's small and I can't get the points to go on the right spot, but I'll walk you through it. Only thing you will do is go through and you will graph those points. So at home, it was 120 at 330. And again, guys, notice that the 330 is on the y-axis because that 120 is your starting point or your y-intercept. Then you will go through and graph the 340, which would be in between 330 and 4. And you will put that point at 65. The 355 will be close to 4, not quite 4, and that will be at 88. 88, notice guys, you're counting by 20s, so that means that every tick mark in between is your 10. So that means 88 needs to be close to that tick mark that's between 80 and 100, but not on the tick mark. Then I go back to 61 at 415. Again, 415, that is dead smack in the middle between 4 and 430 on the x-axis. And then you will go up to where 61, a little bit right above the 60, and put your point there. And then 610 would be not quite halfway, but close to, between 6 and 630 on the x-axis. And you will go up to 95. Again, since the tick mark, I told you guys between 80 and 100 was 90, you need to put it halfway between that tick mark and 100 because that represents the halfway mark between 90 and 100. At the supermarket for 58, you will go to 630 on the X and then go up to 58. Again, close to 60, but not quite 60. And then 72 at 650, that'll be your last point. And then you'll go up to, since the halfway mark are 10s, that makes the halfway point between 60 and 80 is 70. So you need to put your point a little above that halfway point, and that represents your 72. Connect the points and then look to see how your graph looks, what's happening as he's traveling with this car. Alright guys, so I hope this helped. So again, today we looked at interpreting time and distance graph. So basically we're tying everything in about slope that we've been learning, and now we're using it in real life context and using those positive slopes, negative slope, zero slope, and looking at what it means in context, like I said, in real life. So your job next is to work on practice B. And then remember I said tomorrow I will put up a graded assignment, which you guys will do. And make sure you are behaving for the sub because I will be back on Wednesday. And then again, like I said, we'll get our books caught up and then we're ready to move on. I will see you guys later.